we can't do a whole lot of analysis. What ends up occurring is an equation like this. We have really high resolution hazard data, crappy exposure data, which leads to not so great analyses on the other side. And what we work on at World Bank, and my team is sort of an innovation labs part of the Global Facility for Disaster Reduction and Recovery. We work on open data, open source tools to confront that problem in the exposure side mostly. I'm sorry, this is from another presentation. Let me get through here. Oftentimes, we're working with governments and trying to get data out and trying to begin to get them to aggregate the data that they have, which I understand Oakland has got an open data portal, but is still gradually getting things put in the same place. We work a lot with countries that are at high risk for natural disasters and trying to figure out how do we get their data into some kind of common place. Some of that's hazard data. Oftentimes, it's data about the population, data about where the schools are, where the hospitals are, critical infrastructure. It's often inaccessible. Some of this is politics. The ministries don't want to share it because they were under legal obligation to been maintaining it for the past 2 decades, and there's no data. Sometimes it's fragmented, so they may have willingness to put it together, but no one has actually reassembled all of the shards into a picture that can be used. It's often in various proprietary formats, not just one. It's not just ESRI. This is often in old formats. We've run across a few where they've been in projections that have been independently created for that one island, which from a geographic perspective makes it relatively a bit of a pain to get all of the data back reprojected. And usually it's siloed between departments. You know, someone who's working in meteorology, someone who's working on the parcel data. These are in different ministries, different people are maintaining it. And oftentimes the data just doesn't exist. This is Liberia before Ebola. This is actually the Monrovia area. OpenStreetMap has been changing the way that we view crowdsourcing data. This is over the course of 6 months, gradually filling in Liberia, which was pretty much a blank spot on the map. Oakland doesn't quite have the same problem, but I'm going to guess that if you go into the OpenStreetMap data, your information will probably be about the building and maybe its use. But you don't have a whole lot of data about the structure, like what's it made out of, how tall is it, how old is it, what type of construction is it. That's what you're going to need in order to do modeling. This is what we spend a lot of time on in open data. Resilience. We developed a bit of a process. We look at basically 3 parts. First, we listen. We go in and we scope, and we look and say, what analytical problem are you trying to solve? A lot of you are developers, a lot of you are trained on figuring out how do you use use cases to get the things that are actually tangible, tractable, you can do stuff against. It works in international development as well. And we try and look at, okay, what data do you already have? Can we collate it? Can we put it into an open data catalog? We're not going to take it away from you. We're not going to make you put it in one place. You know, the city, I guess, can do that, but ultimately many of our ministries want to maintain their own data and federate it, so creating a place where they can do that via web services. We also work on collecting new data. And a lot of this is with OpenStreetMap. How do we build surveys where we're using field papers, we're using paper surveys on clipboards, and gradually building up an understanding of where our critical infrastructure, and then building out more and more about the residential or commercial infrastructure. And then we need to work more, but we work on how do we begin to turn that into decisions and people's changes to actions. Now, oftentimes we're doing this through relatively simple open source tools which allow people to see the impact of a particular earthquake or flood on their neighborhood and what they can begin to change against that. We always start with a local champion. We almost always work with open source software. Open data, many of you know, but I just want to make sure that we're sort of in the same boat. It has 2 parts. One, it's legally open. There's some open license. Just making it public domain doesn't necessarily make it as open as we need, because it may be taken in, it may not be returned. We also have the problem of technical formats and making sure that the actual data format that it's in is in an open format. We prefer Open Geospatial Consortium standards. and we use a lot, we mandate that for the way that we structure our grants. My group doesn't give out loans, we give out grants, so we're a little bit different from the World Bank. Let me go quickly through the process that we use for collating data. We generally start with a use case, get a campaign in place. This is in essence, grassroots organizing for ministries. And getting a working group together, we commit to take an action, gradually build up open data. We hire a data curator, build it out, and then begin to put that into a data catalog, get a license in place, and then we put it out onto, we created a tool called the GeoNode, which is kind of like CCAN, if you're familiar with the open data platform that CCAN is from the Open Knowledge Foundation or Socrata, except ours is for geospatial information. The GeoNode is it's open source, it's freely available, and what we do is we put up all of the geospatially enabled data sets into one or more GeoNodes. This is a good example of a problem that you all probably have. This is Sri Lanka, 258-page report that provided a very detailed analysis of all of their natural hazards, landslides, earthquakes, tsunamis. This is actually the Batticaloa, which some of you may remember from 2004 was the worst hit area of Sri Lanka. We worked with Disaster Management Center to turn those PDFs into layers that got put into the GeoNode, and now they're all available as web services. If you want the WMS feed for any one of the hazard layers, you can now go pull them out and pull it into your GIS and then do analysis on it, which makes a big difference for the government, because now everyone can work off the same hazard layers, and they can begin to do analyses that look at how bad it's going to be. And that, in the upper left, if I could zoom in, we show you the tsunami. That's actually an analysis of how bad a tsunami would be in Batticaloa of a particular magnitude. I don't remember the magnitude off the top of my head. It's a little bit too small to read. Collecting new data, we work mostly with OpenStreetMap. We try and look at what data we can import first, because we can bootstrap. And then we build out a survey process where we look at what use case you have and what data points do you want to collect. Gradually building up a set of field surveys. We train teams to go out, bring it back, they enter it in, and then we have a second team, usually we hire an engineering firm, to go and do spot analyses on what teams are doing, so we can gradually teach the teams over time, or the engineers teaching the teams what to look for in the buildings. And they become smarter, and then data gets better, and as we enter it in, we gradually get this feedback loop going until there's actually a honest-to-goodness survey capacity in the local population which can maintain the data, and then gradually build that up over time and maintain it and curate it as it goes through. Then we hire a university at the end of what we view as our goal to do a full quality assessment report. This has been critical for us, this extra step, for getting it into the national mapping agencies to accept crowdsourced data as official government data. And we found that this report, coming from usually a GIS professor or a geography professor, and going through the data and showing how accurate is that road against a different reference data set, that's been the thing that's allowed us to get data into full government use. And I think there may be some analogs to begin to look at some other crowdsourced data, the way we can do that. Usually the process looks like this. We have a form, it's relatively simple. We have a couple of key points on this, is that there's a surveyor name, we know who did it. There's a field paper ID, which is actually linked to a second piece of paper. Field papers allows us to print out the map underneath, and we usually, all the geographic data is embedded in that QR code in the lower right. And then we write building numbers for all of the polygons that we've traced off of satellite imagery. And they can begin to put those building numbers back on the survey form and the field paper ID, and with that we know what piece of paper and what building number on that piece of paper associated with this data. It's a relatively simple paper process. It allows us to get around not having cellular networks with our HTML5 apps to be able to enter this all in. We need something where we can actually work offline. This has been something we've been building up a lot of geographic data. Usually we then have them entering stuff either in DOSM, or we use a lot of ID editor for OSM, and getting them the data in and getting all of the attributes for those polygons that they're gradually adding in. This gets us to a point where we can do QA. And importantly, we get to the next step, which is a tool that we built called InnoSafe. This is, we've partnered with the Australian government, the Indonesian government, and the World Bank to build up an open source tool. It goes into Quantum GIS, QGIS, which is a free GIS tool. It's a plugin. You just go into the plugins, download InnoSafe. And it allows us to take in scenarios. In this case, we built a flood model for Jakarta. We took the school extract data from OpenStreetMap, and then we ran the two together and looked at what schools would flood if we put 1 meter of water in Jakarta. And we can do this for other hazards, for earthquakes, like what hospitals will fall down, and begin to look at that by pulling these models in. We need the attributes in OpenStreetMap to do that. It's not just the polygons. We actually need to know what's the building made out of, and how tall is it. But this gives us a really simple tool for one run. This is not risk management. This is just one impact of what might happen. For us, for local disaster managers, this is really easy to teach, free, updatable, and we can get them to use it because they can look and go, that's the school that I put supplies in. It's going to flood. And they can begin to look at a different set of options. Another thing that we've looked at is how do we change policy around data? This is a different part of my life. I spend a fair bit of time working with a set of experiments down the coast at the Naval Postgraduate School, where we get to bring in technologists about 4 times a year for about 4 or 5 days to work on hard problems that can only be solved when you bring multiple organizations together. I do this with National Defense University as a contractor, and I work to basically pull in smart people to work on hard problems. Usually people with heart of the solution. In this case, after Haiti, how many of you are familiar with what happened in OpenStreetMap? All right, let me see whether I can get this playing. This is Haiti before the earthquake. It's one of the most poorly mapped countries in the world. Over the course of 2 weeks, 640 mappers made 1.4 million edits to the OpenStreetMap database. The only time this has been surpassed, there's only 2 times this has been surpassed. This has been for Typhoon Haiyan and for Ebola. This was the first time this was ever done, mapping a third of a country in 2 weeks. That's about a year of cartographic work. That and all those blue dots are all the displaced peoples counts. This changed the perception of OpenStreetMap in the US government. People wanted to use it. And we had the State Department, the National Geospatial Intelligence Agency has a very small unit that works on disaster assessment. It's an awesome team. And then we have work with FEMA and a few others. We were looking at how do we get satellite data to allow that kind of tracing out of the US government legally. Can't use the military